Alright everybody. Hey, I'm Mike. I'm going to go over furnace diagnostic today, and this one is going to be gas valve. So let me go ahead and run to the thermostat and get a call going for heat. Today is to show you guys some basic diagnostics that you can do at home without any tools. Now this is knowledge based. That's what separates technicians from installers. So what we have here, identify this as a Lennox 80% upflow furnace. How do I get that? Well, I installed this furnace a long time ago, and I know that it's a Lennox. This is right here on the door. 80%. Now you could tell that by the venting. If it's metal, which don't touch it because it's going to get hot, because it's metal. It's a lot of extra heat going out the vent as wasted heat. 90% efficient furnaces won't have metal vents. They're going to have PVC vents, and there's usually two of them. One's an intake, one's an exhaust, and that will tell you whether it's an 80% or 90+% efficient furnace. So, how we're going to diagnose these, this one is obviously running right now. It's my furnace, it should be. So what happens first? You get a call for heat from the thermostat. It takes the 24 volts present at the control board and it sends it out to the thermostat. That's present all the time until you make the selection with the thermostat yourself. You say heat, turn it up, it's going to take that 24 volts, it's going to allow it to come back to the control board, and the control board will activate heat. So, first step in heat, other than you telling the thermostat you want it to get warmer, is the inducer motor, the induction motor, the draft motor, whatever you want to call it. Draft motor. And this helped to create the draft and create a lot more efficiency out of the furnace. So you could have a lot more turns now in your heat exchanger rather than just maybe one or two, because you need that heat to go up. So you're able to actually get a lot more heat out of the heat exchanger. This is the inducer motor. Inducer motor starts up, it pulls the negative pressure through the heat exchanger. The heat exchanger needs that to allow the flames to go through, and then it verifies that there is a negative pressure with this pressure switch. It's hooked up with a little tube, and if it's blocked, it's not going to allow anything to happen. So the next thing that happens after we get verification there's a negative pressure inside the chamber, we're going to get the, not this guy, sorry, we're going to get the igniter to glow red hot for about 15 seconds. And then it's going to release the gas. The gas is going to travel from one burner all the way to the end, the last burner, and then this flame sensor here is going to verify that there is flame at the last burner. If not, it'll restart the cycle again. And then after it runs, it'll go for about 30 seconds, and then the blower motor will come on. Okay? Now this is all just what knowledge you need to know about a furnace before you walk up to it. If it's an 80%er versus 90%er, the sequence of operations is primarily the same, but there's a few extra steps. So for instance, there would be multiple pressure switches. There might be multiple stages to the inducer motor. There might be multiple stages to the gas valve, and you could have that on 80%ers and 90+% efficient furnaces. Okay, so let's get into the fun part, the diagnosing. Okay, so if this isn't running properly, what are we going to see? Now first off, I'm going to overheat it because I'm going to turn it off right now. Bam, gas valve first. My inducer motor is still running. My blower motor is still running. I have the blower set to be on all the time because of my Remy Halo, and that way I can circulate air through the house. So what it should be trying to do now is it should get into restart. So I'll put the light down. Can you see that little orange glow? So that tells us inducer motor spinning. It's verified its negative pressure. It's getting the igniter hot. It's getting ready to release the gas. 15 seconds, remember. And there was no gas. So just by knowing what the furnace is supposed to do, you can understand what's wrong with it right now. No tools needed. Let's watch it again. Inducer motor. Some furnaces it'll actually stop and then restart. This one is just going to keep it going. But sequence of operations is the same for all the furnaces. Inducer motor, verification of the negative pressure. The red glow of the hot surface igniter. Release the gas, the verification the gas has made it to the far burner, and then the blower motor. If you remember this, you will learn how to diagnose a furnace without tools. You see it? And so typical furnaces have 3 tri-lockout, because they don't want to just be releasing gas over and over again. You see how it actually stopped this time? That's for safety. Now, there is always the option, so like that the control board isn't sending the 24 volts to the gas valve. If you're a tech and you have a multimeter, it's easy enough to test to confirm here and here is there 24 volts. If this is a multi-stage gas valve, you're going to have to know which one is your common and which one is your low versus your high wire, and which stage it's trying to kick into. Either way, that's how you would test it. Without tools, you're not going to get the 100% verification that it's the gas valve versus the control board, but you will know this is working, this has been verified, the igniter is working. So at this point, it's either the gas valve or the control board itself is not sending the voltage to the gas valve. If that's the case, what you want to do is look at your control board for any visible signs of burn, smell anything that smells like burnt plastic, look for any charred wires, anything to that effect, and diagnose a gas valve without any tools. Now I'll make more videos like this going forward for the future, and in true